For this machine learning project, we are trying to predict electric energy output using the machine learning model. So the data set that was provided contains 4 feature sets, which is the temperature, which is in a range of 1.81 centigrades to 37.11, and the ambient pressure, which is in a range of 992.89 to 1033, the relative humidity average, which is in a range of 25.56% to 100.16, and the exhaust vacuum is in a range of 25.36 to 81.56 centimeters. The target value that we are trying to predict is the net hourly electric energy output, which is the PE value. The analysis. So what kind of the algorithm or the model that you're going to use? I mean, for this scenario, we would start with a regression algorithm or a model. The output metrics that we're going to leverage is the mean square error, mean absolute percentage error, and coefficient of determination. To start off with your prediction, you will start using all the features that are provided within the data set and check the model prediction. The other models that can be considered after you do the regression is the lasso and the ridge regression. The approach that we took to solve this machine learning model is using the Google AutoML, which is no-code approach. So to start off with, I've created a global cloud account, imported the data set provided from in the course, and then selected the target column as a PE. The screenshot that you see here is the columns and also the target that was selected as a PE and the data set that was imported from the sample file. Once the data set has been created, you would then start off with training the model. So as the Google ML model automatically splits the data, which is the 80% of the data that was imported was used for training, the 10% for validation, and the 10% for the training. To start off with, the first model that we're starting, we're going to use all the features that were provided and select the training budget as a value of 1, which is the node. So for this, I mean, once you do the four feature selection, you can see the results that were provided, which is the regression model. The RMSE is 3.701, the R square is 0.954, and the mean absolute percent MAPE is 0.56. So we started with another feature set. Now, instead of selecting all the four features, we started with 3 feature set, which is T, AP, and V. And with this, you can see that the R square has increased to 0.969, and the mean absolute percentage error has reduced to 0.44%. The third model that we selected, we used only the feature set, which is T and V. For this, we did not get the same R square error high as compared to the 3 feature set, but however, we have the increase in MAPE percentage. Final selection for the model for the feature set is we went with the 3 feature set, which is AP, AT, and V. We're using the regression model, and you can see the prediction, the baseline prediction value, which was 455.099, and the model gave us the value was 453.232, which is very close enough. And you can see from a feature set perspective of AP and AT, the importance of AP and AT value that was contributed to the baseline prediction value. And again, for this model set, the R square was 0.969, which is very close enough, and it has a low MAPE value, which is 0.444. So again, for the analysis of this, we use the regression model using the 3 feature set. Thank you.